Okay, let me share my screen here. Okay, so as I go through, there's a lot of content here. It's a lot of deep content. Particularly, what I want to focus on is when you look at the 800-207. It's a 59-page document. It's pretty extensive, but there's a lot of nuances within this document. A lot of verbiage and phrases that have some pretty important implications. And then there's also this other document here that came out on May 6th. It's a follow-up to the 800-207, which is the CSWP20. Which double clicks on some of the terms and some of the concepts that were discussed here in the 800-207. So what I want to do is go through these slides here to basically double click on the gotchas and the things that you'll run into, or the things to think about as you implement the memorandums and implement NIST 800 Zero Trust, according to the way NIST sees it. So this scenario here, we'll assume a 60,000 user network, which is hybrid, a multi-cloud strategy with, there might even be stuff in AWS GovCloud on-prem in a data center, as well as some SaaS applications, particularly Office 365 and Teams can be pretty interesting and challenging. So I want to cover how you would approach that while still meeting the NIST principles for Zero Trust. As you think about NIST as well, this obviously is pretty nice because it fits into the risk management framework, the RMF, and also all of the controls you find in the 800-53B. Many of those controls are really centered around access controls, which for the way, when you think about the 800-207 and the core of Zero Trust, it really is about resource access. So one of the other things here is, as I go through these slides, I'm going to go relatively quickly. There's a lot of content. These slides are mapped in sequence to this document. So later, if you get these materials, you can actually use the slides to compare the sequence of how they lay this document out with the particular sections to get those core concepts. So particularly, what I'll start with is within the Zero Trust basics, which they kick off here in the beginning of the document. And I think these basics are subtle but pretty important. The definition for Zero Trust really focuses on this crux of the issue, which is to prevent unauthorized access to data and services, coupled with making access control enforcement as granular as possible. The 800-207 is about resource access. Ultimately, there's a binary decision that's going to be made whether to grant or deny access to data, service, or application. And all of the things and inputs that we're going to talk about, authentication, trust algorithms, adaptive access, ultimately spit out an answer, which is grant or deny access. This is obviously to reduce breaches. Particularly a lot of the memorandum that came out on January 26 talks about logging, per request logging. One of the really critical components of Zero Trust and what they call the policy enforcement point or the gateway is its ability to do per request access decisions. Per request is going to be really important because typically authentication, authorization are occurring at the point of login. After you log in, you're authorized access to a resource or an application. But the goal here is after login, for every single interaction with a data, an application, or a service, there needs to be not only a decision made, but a log event generated. And that log event's going to make it into your SIM. It could be, Splunk, Sentinel, QRadar, but also within a service so that you can log all of these transactions. In addition, continuous and adaptive access is a possibility when you have per request access decisions. For example, a session gets hijacked midstream, there's an attempt to be used in China, Russia. The per request access decision can reject that request, even though the user's already been logged in. They talk about resources here within the 800-207. The resources are going to be, again, applications, services, or data. This is actually a pretty important concept because a lot of times Zero Trust or the term ZTNA is used to represent on-prem resources. And I know there's I jumped in at the very end here talking about how we think about public internet and granting access to resources. The reality is that NIST sees every resource sitting behind a gateway or behind a policy enforcement point. So technically the resource is private, whether it's Office 365, an RDP session like remote desktop, or some data like a Word document sitting in SharePoint. But a resource can be any resource, any enterprise-owned resource. This isn't the public internet. This is really focused on the applications and data that you own. And then ultimately, it provides access control, the logging, which is really critical for the memorandum, and the security, the DLP, the malware, the CASB. Particularly, I'm actually, by the way, I'm connected to the the Zero Trust service as I'm doing this. But the idea is that the connection that I'm connected to is completely untrusted. Whether I'm sitting in an office, sitting at an airport, at an airplane, it's just a form of transportation, which is also why you see in the memorandum references to encrypted DNS everywhere, DOH, because every packet that leaves my device is going to be encrypted, whether it's a TCP connection or a DNS query. It's using the transportation to get that query to the service itself, which resolves the DNS and provides a response and routes the connections. So in essence, you're almost in a private network globally for access to pretty much anything you need from an enterprise. And the connection itself is always untrusted, whether you're in the office, a data center, or you're working from home. So the way I like to think about the Zero Trust concept from NIST is think of it as an airport security checkpoint. They actually use the airport security checkpoint, particularly within the examples that they give here. They talk about this implicit zone. You have a device trying to access a resource. You have a policy enforcement point, and you're trying to make decisions of whether to grant access or deny access. They use an airport security checkpoint or a screening model in an airport. I really like this model that they chose because what's going to happen is you're going to put a gateway or what they call policy enforcement point in front of the resource. And then the users, as they want access, we want to both authenticate and authorize the user. Authentication is knowing who the person is. So this is the equivalent of someone at the checkpoint presenting their state-issued ID or their passport. In the case for digital assets, this is someone doing basic authentication through like Okta, Ping, Azure AD, or using multi-factor authentication or CAC authentication. That's for STEPA. Authorization is giving someone the privilege to access the resource. This is basically giving someone the ability to cross the checkpoint and access the plane. And in this particular case, when they cross the gateway or they cross the checkpoint, you're going to give them access to an application or some data that sits within the enterprise that you're trying to protect. Concepts like step-up authentication or client certificates are going to be really important. Step-up authentication is we don't trust your state ID. We want to see your passport. For our world, it's going to be multi-factor authentication. Federated identity is going to be really important as well. And it's something that Zero Trust can provide. So you're going to have a lot of legacy applications sitting in a data center. Likely they don't support modern auth, but the memorandum requires modern auth across the enterprise end to end. The nice thing about a Zero Trust service is it can perform the modern auth for you before you grant a connection to even a legacy app that doesn't support modern authentication. And then client certificates, making sure that they're enterprise-known laptops. We want to make sure that maybe an equivalent of a checkpoint, it's going to be the TSA pre-check or something similar, so that it's your devices going and accessing your resources. So you're going to want to get federated identity in place to make sure you have authentication. The Zero Trust is going to provide the logging capability as well as the access controls, and as well as making everything private. The unit of a session here. This quote is particularly taken from this planning guide. So there's actually a lot of nuanced points here. So this CSWP20, there's actually a bullet point or a very small footnote that sits here. And I think that they wanted to be very particular with this because if you look at the memorandum, it talks about logging every single access. So if you look at this, the unit of a session can be nebulous and differ depending on the tools, architecture, et cetera. The basic definition of Zero Trust context is a single connection utilizing one resource, one network identity, one privilege for that identity, a read, write, or delete, or even a single operation similar to an API call. So the concept here is a session doesn't mean, you turn on a VPN, do multi-factor, do device posture checks, and then grant them access to a server. they're taking a session down to the application level and actually every single request to that application. So if you're doing a read or write or delete to a database, you're going to want to not only grant or deny access, you're also going to want to generate a log event for each and every one of these. So setting the right foundation up front is going to be really important. Otherwise, you'll be left with gaps, particularly for the logging gaps and the access control gaps. So understanding this notion of a session is going to be critically important to get this right, even if it means that you can't get down to that granular level, down to a single application. You want to have the framework in place so that as you start tightening your controls, getting more visibility to logging and basically eliminating east-west traffic completely, that you're not having to like re-architect or redeploy a platform, because that's years and years of work that could be eliminated up front. So the per request is absolutely critical for the logging, for the memorandum, again, as well as the access control. And in addition to that, of course, from a security perspective, it provides not only the per request access decisions, but also the DLP, the malware, and all of the other security functions that you might have in place. One thing that they showed here in the 800-207, which makes this all possible, is this diagram. So that this diagram in this slide is taken directly from this diagram that they show for Zero Trust Access. In particular, one thing you'll notice about this, which is really subtle, is they drop the word network out of this phrase. So you'll hear terms like ZTNA or Zero Trust Network Access. The way NIST sees this is Zero Trust Access without the network component, because when you're thinking about the notion of a session, as they describe it, this is really not about network access or server access. It's about application access or resource access. And they're pretty clear that their model is about resource access. And to the user, the good example here, if you look at this particular simple model, you have a user that's trying to access some enterprise-owned resource, which is system, data, or application. And the goal of what they call the policy decision enforcement point, this is the gateway, is to grant access or deny access. This site here, the untrusted zone, could be the public internet. It could be a Wi-Fi network. It could be an on-prem network. It actually doesn't matter, because all of this traffic is going to be encrypted. This will make a decision to allow access. This user should never have direct access to any resource, whether it's on-prem, in AWS, or it's Microsoft Office 365. But if you think about resources, and as you tighten down security for a particular network, if you imagine the resource being a server, the worst scenario for a Zero Trust Access is to do something similar to a VPN, where you authenticate, you do device posture checks, and then you give users access to a VLAN or a small segment of a network. This still allows for east-west traffic, because an infected device can move laterally through the network, as well as an infected, not only an infected device, but an insider threat could also cause unnecessary damage. A little bit better would be if the policy enforcement point can actually give you access to just a single server. So you basically tighten access down to just one physical asset. But even better than that would be tightening down to a network, just a network port. So suppose you have a web server running on port 443, a web server like Apache or something like that, an application. If you can tighten it down to the network port, that's even better. But actually, if you get down to resource access, you're going to tighten this down to just the application on that network port itself. So as a user, if there's a server and it's running multiple applications on the exact same network port, the user shouldn't be able to access any other application, even though the application sits literally on that same server on the same TCP 443 network port. So basically, you're squeezing and squeezing and squeezing the surface area down of a resource, so that ultimately to the user, they don't know where the resource sits. It could be on-prem, it could be in the cloud, or it can be a SaaS application. All they know is that they're connected to a service, their data is encrypted, and they're accessing the things they need based off their identity and their group membership. And all of those decisions and security are happening here within the gateway or the policy enforcement policy decision point. So another thing that you're going to notice here is in their diagram, the location of the user is irrelevant, meaning in the office, on the road, but the location of the resource is also irrelevant. So many people will miss this half. They focus a lot on the hybrid workforce, working from home, that sort of thing. And they miss the point that the resources themselves may be on-prem, but they may also be cloud, SaaS, or other things like that. So if you basically eliminate location here, this will give you coverage, zero trust coverage for your logging from the memorandum, your access controls, and your security in every single resource scenario, SaaS, on-prem, hybrid networks, and that sort of thing. So just remember that locations are relevant for both sides of the equation here. They use the word subject, asset, and resource for the three things that are interacting. Subject is typically a user, but the reason subject is used is later. Think of AWS Lambda functions, non-human entities, OT, IoT, because this is the identity that wants to access the protected resource. The asset is typically a laptop, but it could be a server. Again, it could be OT infrastructure. But this is also the side of the equation that wants to access the protected resource. And then the third is the resource that you're protecting itself. They really want you to start with NIST 800-207. Start with the protected resources. Don't start with the public internet. If you start with the public internet, you're going to be chasing a really difficult and maybe even impossible problem to solve, classifying, random websites and applications. But they talk about in the memorandum of cataloging your assets. So catalog your assets, your users, and your resources, which actually by looking at these three things, you're basically solving for that as well, and you're reducing the scope and the size of the problem by minimizing it to just the things you're trying to protect. So don't start with the public internet, start with enterprise resources you own. As you're classifying them, you're also going to label them in terms of impact level. So you would start with the most critical resources first, highest impact, then go to moderate, then go to low, because as you're protecting these resources with zero trust, they're becoming inaccessible. When they're inaccessible, they can't be touched by China, Russia, or any other attacker because you're denying by default. And then you continue to tighten down for the moderate and the low, which eventually makes your entire network, your entire set of resources private all the way through. The tenets here of Zero Trust, the very first tenet is all enterprise-owned apps, services, and data are considered resources regardless of location. This is one of the most important tenets that I think are within the document. And I think that's also why they list it here as the very first tenet. You look at the tenets of Zero Trust, it's the very first one. Because if you get this, if you understand this fulfills those memorandum requirements of cataloging the assets, the users, and the things you own, as well as it makes it clear of what it is you're trying to protect, the surface area of what you're trying to protect. The side effects and the benefits of Zero Trust go far beyond VPN replacement. They cover VDI replacements with browser isolation, so giving contractors and guests access in a protected way to your resources without leaking data to private to bring your own device or non-enterprise-owned laptops. It eliminates backhaul to the data center. It reduces infrastructure. So there's a lot of cost savings, better end user experience, regardless of where users sit, wherever they work. So if you grab these three things, the user, which is the subject, the asset, and the resource. These are the three things that are interacting. They're all going to be cataloged within the service. And then ultimately the policy decision, policy enforcement point, you connect these users and assets to that edge. You connect the resource to the edge. The resource, again, being an on-prem cloud or any other resource. And then this will make the decisions of whether to grant or deny access on a per request decision. The log events will be spit out of this service as every single request goes through it. So you're meeting the logging requirements. That also takes care of selective decryption. So you can decrypt where that's allowed and bypass decryption where it's not allowed. This is here, with iboss, this will be the edge. So this is the area we serve in. These cubes are the policy enforcement points. This is the software. And it's basically connecting the users and providing the security through those connections for CASB, malware defense, and DLP, as users access different resources. So this process is actually not incredibly difficult depending on how you start. We recommend you first start by connecting the resources to the service edge. As long as the service edge can communicate to these resources, you're going to be far along this journey. And then what you do is you connect the users and devices to the same service edge. And once they're connected, the service takes care of gluing everything together. So getting users to where they need to go. It also takes care of the identity requirement within the memorandum, which requires modern federated identity across the board. This can perform modern auth here before the service edge, even though these resources may not support modern auth. So you might have a database, a legacy application that's sitting within a data center. It doesn't know how to tie into SAML or IDPs. The SAML and IDP work can happen here, and the connection then gets granted to the resource and the application afterward. It's a great way to extend that type of that type of requirement. And then as the users connect, again, we generate the log events and produce those to your SIM. It could be Sentinel, QRadar, Splunk, and of course, it stores it within the login databases within the system. Tagging is really important in labeling. iboss provides labeling as well. So as you label your resources, what we use is the 3 security objectives from FIPS 199. This is also NIST publication. They mention 3 security objectives: confidentiality, integrity, and availability. This is data loss, data destruction, and access to the data or service. And then 3 impact levels: low, moderate, or high. High being the most catastrophic impact to the organization. And basically what you're trying to do is assess as you label and you catalog. So you can catalog these within the iboss platform, but as you're cataloging these resources, you're now getting visibility of which resources you should start with first. You're going to want to start with your high impact first, because if those high impact were to affect a data loss situation, that would be catastrophic. You want to make sure you're addressing that, making that private. Or if you get crypto locker that maybe damages the data, or crypto locks it and makes it unavailable, you want to make sure you're addressing that so that you don't wake up to a situation that's a tailspin. Ultimately, Zero Trust makes all resources private, and even if those resources become vulnerable through software vulnerabilities and things like that, you're still protected because they can't get to the front door of that resource. So this diagram, again, is pulled from the NIST 800-207. This is a blown out view of what they show in the most basic form of Zero Trust. They show this here later within this document. It's this document here. But actually, it looks very similar to the initial diagram that they show, where you have a user and an asset trying to access a resource through a policy enforcement, policy decision point. It's just blown out a little bit more. iboss serves as the centerpiece here, as both the policy enforcement and policy decision point, making all of the enterprise resources private. Notice, again, it's not an on-prem resource or a cloud resource or SaaS. It's just any enterprise resource you own. The subject and the system will be connected to this service. The service is going to grant access to this resource only to those users that should be allowed, denying all others. Notice the SIM sits here: identity management, certificate management, threat intelligence, so things like, you can even think of things like CrowdStrike or other endpoints. Everything will feed into the system, because ultimately the more intelligence this has in terms of identity, to authenticate users, the ability for it to generate logs or getting information from other places, this can serve as a centerpiece. So you can bridge additional technology, so you can acquire additional technology or tie MSPs together to not just protect your resources, but to basically build on a really nice foundation as you move forward. So again, we serve here as the centerpiece, the policy decision, policy enforcement point, but it's every single access, every single request, extending authorization, authentication beyond the point of login. I want to talk about these 4 deployment variations. When you go to deploy this, there actually isn't 1,000 different ways to deploy, which is the good news. They actually only show 4 different variations of deployment that cover all of the use cases that you're going to need to meet for the executive order and the memorandum. And particularly these 4, there's 3 that are by far the most popular, most important. The 4th option, I think, is optional. And they describe these 4 deployment variations here in the NIST 800-207 under deployed variations of the abstract architecture. So they describe this in section 3.2. So particularly the first option, which is the most popular, they call the device agent and gateway-based model. You'll notice that they actually call out an enterprise-owned system. So this is a laptop that's owned by the organization. You have an agent that gets installed. And there's actually multiple reasons that the agent is installed and multiple benefits that I'll describe here in a second. The gateway they use the word gateway and PEP, or policy enforcement point, interchangeably. So that you have a gateway here, and notice how tight the gateway is to the protected resource. So this is an enterprise-owned resource. There's no way this device can get directly to the resource. And they're actually, whether this is the public internet, an office network, or a branch office, it doesn't really matter. This traffic is completely encrypted to the gateway, which is the only path here to the protected resource. Much like an airport security checkpoint, there's no way to the front entrance of the plane unless you go through the checkpoint itself. So the agent actually serves at least 2 primary goals. One is encrypting and redirecting the traffic to the gateway so that it can grant access to protected resources. The encryption allows you to connect to any network and not worry about the network itself. You're treating that network as completely untrusted, including fulfilling the encrypted DNS requirement for the memorandum. This will grab all DNS queries leaving the device and automatically encrypt the traffic, whether the operating system supports encrypted DNS or not. Just simply installing the agent will check the box for encrypted DNS for that device. The other thing it does is it does device posture checks that the firewall's on, disk is encrypted. It also checks to see if all of these other requirements for posture are in place. And you're going to need these because the requirement is mandating posture checks for devices to make sure that they're healthy before they access resources. So it solves both of those problems for you automatically. The agents are typically pushed through mobile device management, MDM, things like Intune, for example, or SCCM. So you can do a mass push through group policy in Windows, for example. They install silently. So the users actually may not even know they're there. Most users will not know that the agent's there. Once this agent installs, it automatically will intercept, encrypt, fulfill the DNS requirement for encryption, fulfill the logging requirement, because you're going to have a logging requirement occurring here. And it's just a really quick way to allow the user to work from anywhere. The second model here is really important for hybrid networks. This is what they call the Enclave-based model. And this Enclave-based model, once again, you have an enterprise-owned laptop. You still have the agent. And the agent, again, is doing the posture checks, encrypting the traffic going to the gateway, as well as redirecting the traffic even when they work from home. But they actually don't call this a cloud. They purposely call it a resource enclave because this is most likely your data center, where you have a network where you can't re-architect or restructure. And what this gateway does is it provides access to these resources that sit on-prem to any user that needs that traffic. Remember, this traffic is going to be encrypted, both the DNS and the connections that are coming to the gateway. And so traffic will come to this gateway and grant access to this resource or these resources. If a user goes on-prem, so you get this enterprise-owned asset, and it goes into this enclave, like the user goes back on-prem, that traffic still goes to the gateway automatically. The service should be able to geolocate the user, grant them access to resources without sending the traffic out to the cloud service and back, because that's going to add extra latency and not something that's going to be not just optimal from a security perspective. Doesn't likely make any sense. But this is a really nice model here. I think that it's an important model. And actually, if you look at the way the service edge is designed here with iboss, what we do is we maintain the single zero trust edge here. And instead of shipping the service into the data center, you use iboss GovCloud. So this is the FedRAMP certified service. Users are working from home, encrypted data on this side. They go to Office 365, the data never gets backhauled. One of the requirements of memorandum is they want direct access from users to resources without hairpinning through a data center. So you'll be able to accomplish that through the use of the GovCloud SaaS service. If a user goes on-prem, these gateways run on physical appliances. The software will run on physical appliances that we provide. The user goes on-prem. If there's a resource sitting on-prem, it goes to this policy enforcement point, exactly the same malware defense, DLP, CASB, criteria-based access, and adaptive access. Gets to the resource, the data comes back without ever sending the data out through the data center and back here. So it's basically equivalent policies here as it is here. It also allows users to connect from this gateway to a resource, or from here to this gateway to this resource. So this pretty much extends the zero trust edge to put security and connectivity close to the resource and close to the user. Remember, the location of the resource is irrelevant, and the location of the laptop or the device is irrelevant as well. So this is a really nice model. This enclave as well, we support Azure, so we can run these gateways and policy enforcement points natively inside your own Azure account. So we can stretch that edge not only into the data center and the hybrid environment, into our GovCloud, but as well as Azure, in addition to that in your environment. So you're basically getting one policy, one security, one visibility, logging everywhere, regardless of where the user sits, and in the most optimal form as well. The third model here, and the third scenario, is what they call the resource portal-based model. Notice here that this is the first time that they don't actually use enterprise-owned system. And they do this on purpose because what they show here is this is for the guest, the contractor, BYOD access, risky situations where data ending up on the laptop itself could be pretty bad. So you never want the data from an enterprise-owned document, for example, to end up on bring your own device, because once it ends up on someone's personal C drive or a contractor C drive, you're never going to get it back. It's data loss. So the resource portal-based model is basically the equivalent of what VDI used to provide, virtual desktop, where it puts a pane of glass here, and it doesn't let this data go past this pane of glass. Like, it can't actually touch the drive, but it also serves the purpose of connecting the user to the resource and only the resource that they need. So you can connect a contractor to the resources, as well as generating the log events, because any data that goes to the same gateways or the policy enforcement points will generate log events. So you basically fulfill the requirements for logging, connectivity, isolation, and then the pane of glass prevents the data from leaking to places it shouldn't be leaking to. So it's a great option to replace VDI, but integrate it into connectivity, CASB, malware defense, DLP, all integrated into service. We have this capability natively baked in. So you can just say, put a pane of glass in front of this application or resource. It'll put the pane of glass, but maintain the logging as well, and the security policies. And then this last scenario is what I consider an optional scenario for devices like Android that support personal workspaces and things like that. They can have a sandbox where our apps will run in the sandbox and only redirect traffic to the policy enforcement point for the sandbox and nothing else. But because you have the third scenario for browser isolation, you don't really need this scenario if you don't want any data touching a device you don't own. And so this can be fulfilled with the third scenario, but it is an option for devices like Android that support workspaces as well. The trust algorithms, which they describe after the deployment scenarios here, they particularly talk about. I really like this diagram in section 3.3. They have the diagram here where you have a series of inputs. What they're trying to access. Tell me more about the user. Tell me more about their device. Firewall's on. Disk is encrypted. What are the resource policy requirements? Tell me more about threat intelligence. If we see this beginning to Russia or China or command and control center, we don't want to give access. Ultimately, you want to make a binary decision: authorize or deny access. That's the output of the trust algorithm. These decisions are inside the iboss service, and we're detecting things like beaconing home to a command and control center to flag a device as infected, and we can cut access midstream, so we don't have to wait for the next login. We can cut access on the very next request. But this is also driven by your external signals as well. So this can be an MSSP. This could be CrowdStrike that says, hey, this device is high risk or infected. If it drives these signals, we take care of the response, which means cut access to resources, because we're the policy enforcement point to all the resources that you protected. Without any human intervention, it's instantaneous. The trust algorithms they describe, there's two types, criteria and score-based. The difference between the two is criteria-based is explicit. Allow this group of users from Active Directory or Azure AD to access an application or resource. So you can really map these to your identity provider, allow groups of users to access HR systems, finance, things like that. So the score-based is really the NIST version of what adaptive access or conditional access is all about. So you may have heard of conditional access from Microsoft. Typically gets applied at the point of login, but you're trying to get per request access decisions. So imagine conditional access or adaptive access for every single request after login, and that's what we're providing by extending that using these score-based algorithms. So someone logs into a system, their session gets hijacked in China. They try to use that session or that cookie to access your resource. We see them coming from China, a distance that is impossible in terms of travel. We reject that access even though the session is still valid. So that's something that continuous adaptive access allows you to do. And so, you can also cut infected devices that are infected with malware instantaneously from all the resources, or offboarding employees, insider threat, lost devices. All of those can result in cut access. And this is here a simple example. We're going to do criteria-based access first, the resource. What user is it? What group are they in? Should we give them access? And then we're going to do the adaptive access, which is called score-based access. If the confidence is high for the resource that's in the subject, we allow the request to occur. If the device is infected, our confidence is very low on that device. We're going to reject access on the very next request, and we're going to log that event as well. So you're going to see that for the logging as we fulfill those login requirements that you have as well across the enterprise. So I know that's a lot of information. Ultimately, the way I would summarize this is, if done properly, NIST Zero Trust Access is about resource access. That's what it comes down to, about making all resources private, about not trusting what you're connected to. This could be a home network. Ultimately, I do read the memorandum as direct access means direct access, someone from their home without hairpinning. The resource may sit in your data center, but it'll still be protected by a PEP. but it may be Office 365. We don't want users going to Office 365 directly. That should be anchored to the edge as well, so that there's a virtual wire between the front door of Microsoft Office 365 and the secure service edge. That's possible as well. But ultimately, the users are connecting to SaaS applications, AWS, Azure, on-prem. They don't really know where those resources sit, nor should they care. Everything's done with identity that meets the requirements. All the logging is in place, and that pretty much gets you to where you need to be. So I don't know if there's any questions. I know there's a lot of information. We'll be providing this material as well.
Well, thank you very much, Paul. That was very informative. I enjoyed your take on things and how you presented the information. I know I learned a lot, and I appreciate your points of emphasis. I don't think we have questions online. I was wondering if there's any questions in the room. Anybody'd like to ask? I don't know. It looks like you killed it there, Paul. That was a very good presentation. So I have no questions here. So I just want to say thank you again for your time. That was awesome.